Number 18 and number 19 were either sum or difference formulas. Number 18 was a sine of a minus b. So how do you think I knew it was a sine of a minus b? Well, we have those trusty reference sheets, and on the left you have your sine, cosine, and tangent of the sum and the difference formulas. You look for the pattern, sine, cos, minus, cos, and then sine. And that pattern was sine of a minus b. So this angle represents A, and the 12 degree represents B. So really what you're doing is the sine of 42 minus 12, which is the sine of 30, which yay is 1/2. If you would have typed this into the calculator, you would have gotten 1/2. So if this were a part 1 question, bing bang boom, you type it in. As a part 2 question, you really should recognize that this is the sine difference formula. In the past, normally what we do is you have to reverse this, and we give you stuff like number 19. Now, number 19, I give you a little practice with tangent. I know we've done many sine and cosine, a plus b's and a minus b's, but tangent we seem to try and we neglect it. So tan of a plus b, we get this formula again from the reference sheet. It's tan a plus tan b plus tan a tan b. And before I even begin, I just put sets of parentheses. This set of parentheses represented tan a. This set of parentheses represents tan b, etc. Now in the problem, they told me that the cosine of a happens to be negative 12 over 13. Now, negative 12 over 13 is affiliated with angle A, so I'm going to need a workstation for angle A. It also told me that angle A was in the second quadrant. Now, cosine happens to be adjacent over hypotenuse. So this is my adjacent side. Again, I put it negative because it's the left of the origin. And this is my hypotenuse, which is 13. Now, some of you might have recognized that this is a Pythagorean triple of 5, 12, 13. If you didn't, you could use the Pythagorean theorem. So whenever I need to evaluate anything with angle A, I'm going to use this workstation for angle A rather. Angle B, we're going to need a workstation as well. The information that they gave me for angle B is that the sine of B is negative 4 over 5. They also told me that the angle was in the fourth quadrant. So I draw my triangle. Some of you were asking me, how do I draw the triangle? We want to visualize a bow tie. This is that portion of the bow tie, that quarter of the bow tie, if you will. This is a right angle over here. Sine is opposite over hypotenuse. This is opposite. Notice I put it as negative because it's below the x-axis, and the hypotenuse is 5, and the hypotenuse will always be positive, regardless of what quadrant it's in. This is a 3, 4, 5 triangle. So now anytime I need to reference anything for angle B, I'm going to go to that workstation. So I'm going to need tan A's and I'm going to need tan B's. Tan A will be opposite over adjacent. So tan A is going to be 5 over negative 12. Tan B's is going to be negative 4 over 3. So we go to our trusty formula, and wherever I see tan A's, I'm going to put my negative 5 over 12. And wherever I see tan B's, I'm going to put my negative 4 over 3. Not tan negative 5 over 12. These are sides. These aren't angles. You don't take the tangent of sides. You take the tangent of angles. This is the ratio that represents the tangent of the angle. You type that into your calculator. If you use your fraction feature, it will turn the fraction right away to negative 9 over 8. If you didn't use the fraction feature, which I don't recommend, you should be using the fraction feature, then you would have had a decimal and had to convert it.